All right. Hello, everyone. Thank you for joining me. Today, we will be doing a voltage drop test. Now, if you've gone over the student lesson, which I highly recommend you do before you watch the video here, because it will go over instructions and explain a lot of reasons why we do the voltage drop test. And I also have the student lesson here, and it goes over voltage drop testing. The voltage drop says a voltage drop is voltage consumed, voltage used, or voltage lost. And it is not the same as an available voltage test, which only tells me how much voltage I have at certain points. The voltage drop is also considered a difference of voltage test. What it really is doing is picking two random voltage readings along the circuit, and it's doing a subtraction, a difference, to tell you how much is lost or consumed. And in the lesson plan, we're going to go over what is a voltage drop, how do we do a voltage drop, and on the very last thing we're going to go over here is why. Why do we do a voltage drop? Why is it important? Okay. Now, the very first thing is what is a voltage drop? Okay. Voltage drop is a measurement between 2 points, two random points you're going to pick in the circuit, and it's going to measure how much it's used, consumed, or lost across those 2 points. It can be across a wire, which is a conductor, or a load. You can also do this across a switch or a fuse as well to test how much is being used or lost across those 2 points. Very important here is you got to make sure you do the test while the current is flowing, which is the last thing here in step number 1 in capital in all caps here. Make sure you do it while the current is flowing. Otherwise, there will not be a voltage reading. Okay. So how do we do a voltage drop test? Very important here. You got to make sure the power's on. You got to make sure the circuit's intact, meaning it's completely hooked up. And that will allow the current to flow. And you have to have access to the connectors to start doing your test. Nothing in the circuit must be disconnected. Again, it's very important because if it's disconnected at any point, the circuit, the lights, the motors, whatever it may be that you're testing, will not be functioning. So you got to make sure it is on. Now, a couple things here. I have my light board, I have my power supply, I have my digital multimeter, or DMM for short. And I have a bunch of test leads here along with my test leads I am going to be plugging into my multimeter. Now, a lot of the students will, when they buy theirs, it's going to come with two different colored test leads. Okay, it's going to have a black one and a red one. And my example here, I want to just point out that it really doesn't matter. So I'm going to use just two black ones. So if you run out of, like maybe let's say your test lead was broken or something, you can also use another black one. Okay, it does not matter. It's just the color of the insulation of the wire, and it will work perfectly fine. Now, a couple of things about the digital multimeter. Again, yours might be different. You might have bought it from a different spot, different location. Might have been something your parents might have handed down to you, a family member, a friend, or somebody who just decided they're going to hand it to you because you're going to learn how to use it. So these settings, these test points here will probably be different, but they'll probably be labeled the same way. Okay, so on some of these four outlets here might be in a different spot, but again, they will have these markings on here. Now, where my thumb is at, my finger is at, I have my voltage, resistance, or diode. So if I do any one of those, I want to make sure I plug it on this side. The COM is usually a fixed spot for your test lead. And again, it's color coded on mine, so I'm usually going to put the black one there. The two on the left are amperage readings. So unless you do an amperage test, you want to avoid using these two over here because in this DMM here, there's a fuse in here. There's actually two fuses in mine. So if I leave my test leads over here and I do a random test that I forgot to change the setting on my dial, it could potentially blow that fuse up. So anyways, We're not doing an amperage test. We're only doing a voltage drop, so we want to keep it on this side. So I'm going to go ahead and plug it in. One of the problems I see students doing all the time. Now, when you're looking at me do this video here, it is from the top, so it's hard to see, but I'm going to flip this digital multimeter over so you can see what I'm talking about here. Lots of times students will set this up and you can see the difference in height here, okay? You want to make sure this test lead is fully pushed in, okay? Make sure you push it all the way in to get a good connection and a good reading. So there he goes. Make sure it goes all the way in. Next thing I see students do an error all the time, okay, is the settings, okay? Again, your settings will be slightly different. I'm going to tilt this up so we can see better. But on mine's, okay, I have the test leads plugged in. I have an off setting. From the off setting, I have 2 voltage settings. Matter of fact, I have 3 on here, but I'm only going to focus on the first 2. Do not set it to the first voltage setting here. The reason why is if you look on top of the V symbol here, you'll see a wavy line. That wavy line represents a voltage reading in AC or analog. With my power supply here and my lights on my light board here representing my car, we will be doing DC, digital. So we want to be in the second setting. So that way on top of the V here, you'll see a flat line, okay? That represents digital, okay? So make sure you turn it to that setting. Otherwise, if you turn to the volts AC and you start putting your test leads on there, it will not give you a good reading. And students, most of the time, when they do that, they'll write down the wrong readings on their labs, or they'll interpret it wrong, assuming there's something wrong with the circuit, okay? So I'm going to move this DMM here out of the way. I'm going to put it on top of the power supply here. And mine has a little kickstand in the back. Yours probably will too, just so you guys can tilt it up and get your readings, okay? Right now the multimeter is just fluctuating because I haven't set anything up and haven't done any test readings yet, but I'm just setting it up right now. So I'm going to take a random wire here, random red wire. I'm going to plug it in for the power. And then I'm going to go that to the very far right side of my light board here. And that's going to represent my power side of my circuit. It's going to go into this light bulb. Now out of it, I need a ground wire. Otherwise my circuit is incomplete. So I'm going to plug a ground wire into there. And I'm going to bring that wire to the ground of my power supply. Now that I have that set up, let me make sure I move my test leads of my digital multimeter out of the way so no one gets confused. I'm going to turn the power on and light that up, and the light bulb lights up perfectly. This means, or this shows me that the light bulb is functioning correctly, but we're going to test it because a lot of things in the vehicle will not be a light bulb. So for example, it could be anything from a window motor to a blower motor or a horn, okay? So some of those you cannot see visually like a light bulb. Now obviously the horn, it's not gonna light up, but you will hear it. And a motor, if it's very quiet, you won't even hear it, and you can't see it functioning. So you have to do the test. So I'm going to take one of my test leads here, the one on the volts. Okay, this one here. And I am going to put it into my power here, which is going to read the power source. My second test lead. Okay, I'm going to take that. I'm going to go to where that red wire goes to the light board, the circuit board. Okay, now when I do this test, what I am doing, because again, going back to the student lesson plan, I need to make so on step 1 here, the very beginning, it says voltage drop is a measurement made between 2 points in the circuit to measure the amount of voltage is being used, consumed, or lost. And what I'm really doing here is I want to see how much voltage is being lost in this positive red wire, the power wire. Now when I go to my DMM over here, what it's reading is 30 point, sorry, it keeps fluctuating there, probably because I have some movement on the table here. But what it's reading is 35.9 millivolts, which is very important because lots of times what I see students do is when they write the value, they write it as 39 point whatever volts. Okay. Right now, this value is very minute, very small. And if I wanted to convert it over to actual voltage, I have to move it 3 times to the left, which means 1, 2, 3, which will end up being 0.0, and right now 5.9 volts. Okay, so again, this is a millivolt reading, very minute, which means this wire right here is not using up a lot of voltage, which is ideal. You don't want it to. Had it been using up an actual voltage value, the light bulb here will receive less. Therefore, it will probably be dim. So I'm going to move it now. I'm going to leave one wire in the positive side of the light bulb where the power is going in. I'm going to go to the ground side of the light bulb here. And it should read full voltage. And if I scoot this DMM over here, you can see it's reading 13.75 volts. Okay, not millivolts anymore. Now, what's different now is that's actually a negative reading. Now, I don't want anyone to be concerned about this because a lot of times students do these readings. They're like, oh my gosh, it's a negative reading. Something's wrong, right? No, nothing's wrong. What that's really telling me is that when I did my test leads, they were reversed. The red one, or one of the test leads here, this one should have been over here and vice versa. Now, when I reverse those, the number becomes positive. But as you can see, it is very much still the same value without the negative. So a lot of times I tell students, it is still the same number. Think of it as if you're standing in at a certain point on the number line, you're going 13.75 to one side of the zero, which is the positive, or you're going to the opposite side, which is going to be a negative. But what's important is the distance that you travel from the zero is still the same distance. So when you get a negative reading, it does not matter if the test leads are in the correct spot. They can be reversed to give you the negative reading. When you write it, just be sure not to write the negative because it is still the same value. All that means is your test leads were in the wrong spot or the opposite spot. Now, I'm going to move one of the test leads and I'm going to bring it down to the negative of my power supply. Now, what I'm really doing now is I'm measuring voltage drop of the ground side. Now, if you look at my DMM here, it's also reading a negative 16.8 millivolts, not actual voltage here, okay? Again, don't be alarmed. A lot of times students see this and they're like, oh my gosh, the power supply is only 13 volts. How am I seeing 16, almost 17 volts? It is not an actual voltage value. This is millivolts. Again, keep them in mind, okay? Very small number. And the negative, again, just means my test leads are reversed, okay? So do not be alarmed. Don't need to write the negative, but you got to make sure you write the millivolts versus voltage because the millivolts represents a very small number versus a big number, which is a big difference, okay? Another example for students to understand volts versus millivolts, I usually tell students, think of pennies and dollars. Millivolts is like pennies. So if I lose a little bit of penny here and there, it's not a big deal. But when I lose lots of dollars, you're going to start to notice it in your bank account. And so I always use the analogy of money because everyone understands money. Okay. Now, let's go back. I'm going to turn the power off here for a moment because there's a lot of glare here. And you'll notice that when I turn that off, the voltage drop of the wire, again, it's still hooked up. It went down to almost nothing because right now there's no voltage in the circuit because the power went off, no current is flowing. So it will not read any voltage values at all. Now, I'm going to disconnect that. I'm going to shut this off for now, and I'm going to go to my lesson plan here and go over some remaining things. So, why do we do a voltage drop? Very important. Voltage drop is sometimes referred to as dynamic test, whereas a resistance test is referred to as a static test. when performing a voltage drop test, you are really looking to see how much voltage is lost or used. But I want you guys to understand that that's not really what the voltage drop test is used to do. Okay, the purpose behind the voltage drop test is to see if there's any resistance at all. Okay, if you look at this example here, it says, think of a bathroom sink. Assume there's no restriction, and you blast the faucets all the way on, fully on. If there's no restriction in your piping, no clogging, no buildup, or nothing in the pipes, water is going to flow. It's going to drain without any issues. It won't back up because that pipe is just clean, perfect, no issues. On the flip side, should there be any blockage at all, buildup of hairs, any gunk buildup, rust, or anything in the piping, well, guess what's going to happen? When you turn the faucets on full blast, it's going to start backing up. And you're going to see it start backing up to the point where it will overflow over the sink. That is exactly what a voltage drop is doing. It is actually wanting you to turn the power on, okay? Wanting you to turn the current on. That's why it says you need to have the current flowing. And it will test it live, a dynamic test. It's going to test it live to see if it can actually go through that component without any restrictions at all. Okay, so that's what we're testing here. See if these wires have any restrictions at all. And if they do, usually the fix for it is going to be you're going to find that section of wire and you're just going to replace it. Okay, and this is important because you want to make sure you know how to do the test correctly. Again, a couple of things that I see students do mistakenly all the time. They will not plug these in all the way in. They won't get a correct reading, or they'll plug it into the wrong outlet. The second thing they'll do is they'll put it to the wrong setting on the dial. So make sure you put it to the correct dial. And then lastly, make sure you put the test leads of your digital multimeter here, the red and the black, into the correct spot. If you put it into the wrong spot, again, not an invalid voltage. This is a voltage drop test. You're going to find two random spots across your circuit, and you're going to get a reading. Again, to make sure, again, turn the power on. Okay, if power's not on, you will not get an accurate reading here. All right, so make sure you watch the voltage drop reading link at the bottom here. If you have any questions when we start doing labs, ask questions. And if you still are confused, let me know. And I'll come over and do a demo. I'll watch you guys do it, and I will explain what's happening in the circuit and why you're getting certain readings. Okay, so again, ask questions. Even if you don't have questions, ask for something as simple as, why does it work this way? Why is the reading this way? Simple as the negative reading. That's a good question. Or why is it a 36.7 millivolts versus a voltage value? Ask questions. We'll go over it. Hopefully, everyone will understand. Again, not everyone will, but I'm hoping after watching this demonstration here, everyone will get it. And again, go over to the material, come watch the videos, come to the lab, and we'll do it in person. Answer more questions if you have any. Okay. So thank you for joining me, and again, see you in the lab.